Welcome back, students. To understand example 913, we need to understand how to obtain the solution for this question. Integral -1 to 1 dx divided by root of 1 negative x squared. So I would be using substitution technique. So let x be equal to sine theta. I differentiate both sides. We get, it's always better to write these statements down. Differential of x would give me dx. Differential of sine theta would give me cos theta d theta. So the integral is going to be, I'm not going to be changing any integration, the limits over here. I will do it at the end. So in the place of dx, I would be substituting cos theta d theta divided by root of 1 negative. In the place of x, it's going to be sine square theta. Of course, the limits are not changed. So let us do it at the end. Now this is going to be cos theta d theta divided by, now 1 negative sine square theta is cos square theta. So this is going to be integral cos theta d theta divided by root of cos square theta would give me cos theta. So cos theta can be cancelled, giving me d theta. So this is equal to theta, but x is equal to sine theta. So from here, this means theta is going to be equal to sine inverse of x. You follow me? So this is going to be equal to sine inverse of x. So now you can apply the limits. The limits are given to be as -1 to 1. In fact, you can even state here, okay, with respective limits. Okay, you can either retain the limits or write the statement like this with respective limits. So this is going to be equal to, applying limits, you can write that down. Applying limits, we get, so that is going to be sine inverse of 1 negative sine inverse of -1. Now we know that sine inverse of 1 is pi divided by 2. And sine inverse of -1 is negative pi divided by 2. So this is equal to pi over 2 added with pi over 2 will give us pi. So this is the final answer for this question. So we would now continue on to do the example. The example given to us is 913. We are asked to integrate integral of root tan x plus root of cot x times dx. And the limits are 0 to pi over 2. So what I would be doing is, I know that tan x is sine x divided by cos x, and cot x is cos x divided by sine x. So I would be substituting it over there. So this is going to be integral root of sine x divided by root of cos x positive root of cos x divided by root of sine x within the limits dx. Now I can take the LCM. I'm not changing the limits as yet. I can take the LCM, and that would be root of sine x times root of cos x. Now clearly this is going to be root of sine x times root of sine x, because root of cos x and root of cos x can be cancelled, positive root of cos x times root of cos x times dx. So this is what we have got. So having got like this, I can rewrite this as integral root of sine x times root of sine x will give you sine x, root of cos x times root of cos x will give you cos x, divided by square root of, I can rewrite this as sine x times cos x times dx. So what I'm going to be doing is, I'm going to be multiplying the numerator and denominator by root 2. So when I do that, I would get root 2 times 0 to pi over 2 sine x positive cos x times dx divided by, of course there is going to be a root 2 times root of sine x times cos x. Now I will be moving this root 2 inside and rewriting this as root of 2 times integral 0 to pi over 2 sine x plus cos x times dx divided by root of 2 times sine x cos x. So I have something like this. Now I want you to consider this quantity sine x positive cos x raised to the power 2. So if I were to expand, I would get sine squared x positive cos squared x positive 2 times sine x cos x. I get this. Now, if I were to consider sine x negative cos x, okay, if I were to consider sine x negative cos x whole squared, I would get sine squared x positive cos squared x negative 2 times sine x cos x. I would get something like this. Okay. Now, in both these cases, I'm getting 2 times sine x cos x, 2 times sine x cos x. The only difference is I have a negative sign here. Now, if I use this substitution, if I use this, then what happens? If I were to take t to be equal to, say, sine x negative cos x, and if I were to differentiate this, I would get cos x negative, differential of cos x is going to be negative sine x times dx, which I can rewrite it as cos x plus sine x times dx. So what am I trying to tell you here is, if I were to use this and make the substitution, clearly I would be able to hit the numerator. But the only challenge I've got here is I need to convert this negative to positive. That is simply done by having a negative sign here. So if I were to place a negative sign outside, I would get a positive quantity here. If I were to do that, then this is going to be negative of the entire sine squared x positive cos squared x negative 2 times sine x cos x, which I can rewrite it as negative sine squared x negative cos squared x positive 2 times sine x cos x. Now this is going to be negative 1 positive 2 times sine x cos x. But I need to remove this negative 1 because I don't have a negative 1 here. So the best way would be to add a positive 1. So if I were to place a positive 1 here, it means I can clearly obtain the quantity 2 times sine x cos x. And the only thing that is missing here is square root. So all I need to do is to place a square root here. That would mean I have a square root here, a square root here, a square root here, a square root here, which means I've got the denominator. So let us do that. So rewriting, I can rewrite. So all these things I have done just to explain to you the substitution that I'm going to be doing. So we got root of 2 times sine x, I'm not touching the numerator, positive cos x times dx. In the place of the denominator, I would be now using integral 1 negative of sine x negative cos x raised to the power 2. So let us make the substitution. Let sine x negative cos x be equal to some t. So I would be differentiating both sides, differentiating both sides. We get, so what do we get? Differential of sine x would give me cos x. Differential of cos x would give me negative sine x. So that has to be multiplied with dx. Differential of t would give me dt. So this is going to be cos x positive sine x times dx is equal to dt, which can be rewritten as sine x positive cos x times dx is equal to dt. Now substitute sine x positive cos x times dx to be equal to dt. So this is going to be equal to integral. In the place of sine x positive cos x times dx, I've got dt divided by square root of, in the place of sine x negative cos x, I've got t. I got a square here, so place a square. So the limits are 0 to pi over 2, but we got to change the limits. Okay, so what I would do is I would not place 0 here. So let me just place the limits now for t. So when x is equal to 0, what happens to t? T is actually sine x negative cos x, right? So substitute x is equal to 0. So that would mean I would now have sine of 0 negative cos of 0. Sine 0 is 0, cos 0 is 1, so that would give me negative 1. When x is equal to 0, the value of t is negative 1. So place that limit, negative 1. Now when x is equal to pi over 2, so when x is equal to pi over 2, I know the value of t is sine of pi over 2 negative cos of pi over 2. Cos pi over 2 is 0. Sine pi over 2 is 1. So I have t to be equal to 1. So when x is equal to pi over 2, the value of t is 1. So the limits are negative 1 to positive 1. Now this is rewritten as integral root 2. Just for the clarity's sake, I'm writing it again. Negative 1 to 1. Now dt divided by root of 1 negative t squared. Now in the previous illustration, I've shown you that integral dx divided by root of 1 negative x squared within limits negative 1 to 1 is sine inverse of x within limits negative 1 to 1. When I substituted the limits, I obtained the answer as pi. So using this result, okay, this integral negative 1 to 1 root of 2 times dt over root of 1 negative t squared will now be equal to root of 2 times pi. So you can write it as pi times root 2. So this is the final answer for the question.